Hi everyone. So in this video we'll be understanding the intermediate value theorem. So I won't be going into the proof but just a graphical representation of the same. So we will take a function f and it should satisfy the two conditions. First, it should be continuous. That means we cannot pick up our pen while drawing the function. And the other thing is the function should not take a drastic jump. And the other thing is it should be well defined on the closed interval AB. That means that it should specifically well defined on the endpoints of A and B. Now we could have drawn any function that satisfies these two conditions. It could have been any roller coaster like or a very simple function, but still for simplicity I am going with a very simple function. So now let's go to the statement. It says that for any value of L between the values of f of a and f of b, so I take a value of L and it could have been anywhere between f of a and f of b, anywhere here. So it says that there exists a number c in AB. So for understanding I have drawn this line and we can see that at this particular point the line cuts this function. So we will denote it by C. So there exists a number C in AB. So yes, this is inside our interval for which f of c equals to L. So we can see that f of c equals to L. So now we are getting only one such value of c. But if I had drawn any complex function like this, I can see that I would have got many values of such c. So it says that there exists at least one value that this condition satisfies. However, there can be many such values. So let's take a better understanding of this. And let me draw a function that does not satisfy this particular property. So I have taken again a point L that is between f of a and f of b. And my aim is to draw a function between these 2 points such that it should not cross this black line. But we can see that it's nearly impossible to draw such a continuous function that does not cross this black line and reaches the end point. So we can say that every function that is continuous will surely achieve this point L. So here in this case this particular point will be our C. So there is one more statement to be observed, and that means that this L we have, it's actually arbitrary. It can take any value from f of a to f of b. So f will take on every value. That means f will take on every value between f of a and f of b over the interval. So every value between these 2 points will be achieved by this particular function as long as it is continuous and defined on the endpoints. So this was the graphical representation of this intermediate value theorem. I hope you guys understand. Thank you.